Have you ever wondered how data packets navigate the vast labyrinth of the internet, always finding their way to the correct destination, sometimes across continents? It is a marvel of engineering, guiding countless bits of information along the most efficient paths. At its core, a next-hop internet protocol address entry is primarily determined by a router's routing table, which is built from information gathered through various routing protocols and configured settings. This entry points to the next router or device on the path that a data packet must take to reach its final destination network. The routing table is the brain of the router, a sophisticated database storing all known routes. When a data packet arrives, the router examines the packet's destination internet protocol, address, and compares it against entries in this table. This comparison is not a simple exact match but a process known as the longest prefix match, where the router chooses the entry with the most specific network address that still encompasses the packet's destination. Routes are populated into this table in several ways. Firstly, there are directly connected networks, which the router immediately knows about because it is physically connected to them. Secondly, static routes can be manually configured by an administrator, providing explicit instructions for specific destinations. These are often used for small networks or for pointing to a default gateway. Thirdly, and most dynamically, routing protocols like Open Shortest Path First, or OSPF, and Border Gateway Protocol, or BGP, constantly exchange routing information with neighboring routers. These protocols use complex algorithms to determine the best paths based on various metrics, such as hop count, bandwidth, and delay. For instance, OSPF typically favors paths with lower cumulative cost, while BGP focuses on policy-based routing and path attributes for interautonomous system routing. Each protocol calculates its own best path, and then the router uses a concept called administrative distance to decide which protocol's route to trust more if multiple protocols offer a path to the same destination. A lower administrative distance indicates a more trustworthy source. Understanding these underlying mechanisms empowers network professionals to design robust and efficient networks. By knowing how next-hop decisions are made, administrators can strategically configure static routes, influence dynamic routing protocols, and troubleshoot connectivity issues more effectively. This knowledge is crucial for optimizing data flow and ensuring reliable communication across diverse network infrastructures. For instance, influencing a router's decision means you can direct traffic away from congested links or towards preferred paths for security or performance reasons. A fascinating aspect often overlooked is equal-cost multipath, or ECMP routing, where a router might have multiple equally good paths to a destination. In such cases, the router can distribute traffic across these paths, increasing bandwidth and resilience without changing the next hop address itself for a single flow. Instead, it varies the next hop for different flows or packets. This intelligent load balancing adds a layer of sophistication to network design. Another key concept is route summarization or aggregation, which allows a single route entry to representing multiple smaller network addresses, significantly reducing the size of routing tables and improving lookup efficiency. This is vital for managing the immense scale of the Internet's routing information. Ultimately, the determination of a next-hop Internet protocol address is a sophisticated interplay of direct connections, administrative configurations, and dynamic protocol algorithms, all weighed against specific metrics and priorities. By mastering these principles, you gain a powerful lens through which to view and manage the intricate dance of data across global networks, ensuring information reliably reaches its intended destination every single time.
If you love understanding how the web works, like, subscribe, and stay connected with us.